Hello students, in this module we'll discuss about the potential energy of a satellite and the kinetic energy of the satellite. In the previous modules we understood what is potential energy and gravitational potential. Okay, on the basis of that we'll be discussing potential energy of the satellite first. Now potential energy of a satellite revolving around the earth is always given as minus GMM upon R, which we have done in the previous module, as in written as U is equal to minus GMM upon R, where capital M is the mass of earth, small m is the mass of the satellite, and small r is the radius of the orbit in which the satellite is revolving. Now if the satellite is at a height, considerable height above the surface of the earth, then the formula is written as PE is equal to minus GMM upon R plus H. And if it is very close to the surface of the earth, then H is negligible and the formula becomes PE is equal to minus GMM upon capital R. Remember this fundamental formulas for potential energy of a satellite. Coming to kinetic energy. Kinetic energy of a satellite, fundamentally kinetic energy is always given as half mv square, right? So I can say in this case the satellite is revolving in a circular path, so its velocity would be linear velocity, would be critical velocity Vc. So kinetic energy can be written as half mvc square, where Vc is the critical velocity with which it is moving in the circular orbit. Small m is a satellite's mass. Now you know what is Vc? You know that the critical velocity or linear critical velocity Vc for a satellite is always given by a formula which is done in your previous module. You remember? Yeah, what will be the formula for Vc? It was, yes, root of Gm upon R, where small r is the radius of the orbit in which the satellite is revolving. So if I substitute this Vc in the main expression, I get kinetic energy is equal to half m into Vc square. So Vc square, so root will get cancelled. It will become brackets Gm upon R. If I just rearrange this and write it properly, I get it as kinetic energy is equal to Gmm upon 2R, which is the formula for kinetic energy of a satellite revolving around the earth. Now, in a similar manner, how we discussed for the potential energy, two cases at a height close to the surface, same way, if this is the fundamental formula for kinetic energy of a revolving satellite, then on the pattern at a height, we consider the kinetic energy formula to be changing as per the notations shown in the diagram. If it is at a height, then let's say the height measured from the surface of the earth is h and the radius of the earth is taken as capital R, then the entire radius of the orbit will become capital R plus h, and the kinetic energy will be given as Gmm upon 2R plus h. Similarly, if the satellite is revolving very close to the surface of the earth, so very close to the surface of the earth means the height above the surface of the earth, that is h, is negligible. So I have not considered h, means the orbital radius is same as the radius of the earth, means it is same as capital R. Then in that case, the formula for kinetic energy would reduce to Gmm upon 2 times capital R, and this is your expression for kinetic energy at a height and close to the surface.